Hello students, here's a good news for you all. You can now watch my videos in Hindi also. All you have got to do is go to the specific video, click on settings, next click on audio tracks and then change the language settings from English to Hindi. You now have the dubbed version of this video in Hindi. Hello students, welcome back. Let's take up another board question, and this question is from electricity chapter and this carries a total of 5 marks. As shown in the diagram, an electric circuit consisting of an ammeter, a voltmeter, 4 cells of 1.5 volt each, a plug key with a gap XY was set up. Voltmeter and ammeter readings were recorded in the observation table for 4 arrangements as given below. Arrangement number 1, only resistor R1 in the gap XY. Arrangement number 2, only resistor R2 in the gap XY. Arrangement number 3, resistor R1 and R2 in series in gap XY. Arrangement number 4 has resistor R1 and R2 in parallel in gap XY. Now there is a circuit in which there is an ammeter, there is a voltmeter, and there are 4 cells of 1.5 volt each are connected with a key, and there is a gap XY in which we have a combination of resistors which are connected. Now the battery has a total of 4 cells and they are of 1.5 volt each, so the total potential difference comes to be 6 volt. Now in the first arrangement, only the resistor R1 is connected and the current is noted down. In the second case, only R2 is connected and the current is noted down from the ammeter. In the third arrangement, resistor R1 and R2, they are connected in series and the corresponding current is noted down. And lastly, in the fourth case, the resistor R1 and R2, they are connected in parallel and the corresponding current is noted down. After the data was calculated, it was plotted in a graph which is shown here. Now based on this graph, we have to answer some questions. They are, the first question is, based on the observation of 4 VI graph, A, B, C and D as shown in the figure were drawn. Study this graph and say which of this graph represents the series combination of R1 and R2. Now we know that in series combination, the resistance of the overall circuit increases because RS is R1 plus R2. So when these two resistances are added up, the overall resistance of the circuit increases. It is more than the individual resistors. So this increases the overall resistance of the circuit. Next, for the parallel combination, which of these graphs represents the parallel combination of R1 and R2? Now when resistors are connected in parallel, the overall resistance of the circuit decreases and this is even less than the individual resistors. So the overall resistance decreases when we connect the resistors in parallel. So the arrangement of resistance in series increases the overall resistance of the circuit, whereas the parallel combination decreases the overall resistance of the circuit. Now we have to find out of these 4 which represents the connection in series and which represents the connection in parallel. Now these lines represents the resistance in the VI characteristics graph. So let me tell you an easy way. Now see, the potential difference which we have given in the circuit is constant. Now for that constant potential difference, when we connect them in parallel, we get the maximum current, and when we connect them in series, we get the minimum current. So for this graph, let us understand that for a particular voltage, which combination is giving us maximum current and which combination is giving us minimum current. So take any voltage here, mark any point over here and just draw a straight line parallel to the current axis, cutting these 4 lines representing the various combinations. Now for this voltage, this line cuts the first slope at this point, the second slope at this point, the third slope at this point and the fourth slope at this point. Now join all these 4 to the current axis. Now this is the value of current which is increasing. So this one has the least current value and this line which cuts the current axis at this point has the maximum value. So the line A has the least value of current and the line D has the maximum value of current. Now the maximum value of current, we know that it is possessed by the combination when these resistors are connected in parallel. So this line D represents the parallel combination which has maximum current. Similarly, the slope A has the least value of current, and the least value of current is possessed when the value of resistance is maximum. So the current value will be minimum in this case. So this slope A represents the series combination, and here the current is minimum because resistance is maximum for the slope A and resistance is minimum for the slope D. So just you have to do is, at a particular voltage, draw a line which cuts all these four slopes and then draw perpendiculars from these junction points onto the current axis. The line which shows the maximum value of current will be the one which has the minimum value of resistance, and that combination would be the parallel combination, and the line which shows the minimum value of current is the series combination which has the minimum value of current because it has the maximum value of resistance. So in this way you can identify the slope of the graph which possesses minimum value of current and maximum value of current. We can also say that the slope which has the minimum elevation, which possesses the least steep slope, this theta is minimum, so the resistance will be maximum. Similarly, the slope which has the maximum value of theta, or the slope which is the steepest of them all, will have the minimum value of resistance, that is, it will have the maximum current. So we can write the answer for A is, which represents the series combination. So series combination is possessed by A. Then which represents parallel combination, it is D. Now coming to the next bit question, show an arrangement of three resistors, each of resistance 10 ohm, so that the combination has a resistance of 15 ohm. Justify your answer. So there are three resistors, each of value 10 ohm, and they are to be connected in a definite combination so that to get an overall resistance of 15 ohm. So there could be four possible options. The first one would be connecting all of them in series. So we know that the equivalent resistance in series is given by addition of the three resistors. So it is 10 plus 10 plus 10, which is 30 ohm, which is not 15 ohm. So this is ruled out. Next we have all of them in parallel. We know that the parallel combination is given by 1 by Rp is 1 by 10 plus 1 by 10 plus 1 by 10, which is 3 by 10, which implies that Rp is 10 by 3, which is again not 15 ohm. So connecting all the three resistors in parallel also doesn't give us an equivalent resistance of 15 ohm. Next combination we can connect is two of them in series and one in parallel. So connecting them in series, Rs is 10 plus 10, which is 20 ohm, and then this equivalent resistance will connect in parallel with the other one. So it is 1 by Rp is 1 by R1 plus 1 by Rs. So this is Rs. So whose value is 1 by 10 plus 1 by 20, whose value is 20. It is 2 plus 1, which is 3 by 20. And Rp comes to be 20 by 3 ohm, which is again not equal to 15 ohm. Hence this combination is also ruled out. So now coming to the fourth combination, we have two in parallel and one in series. Let's see what the answer is coming. So for the parallel ones, it is 1 by Rp is 1 by 10 plus 1 by 10, which is 2 by 10, that is 1 by 5. So 1 by Rp is 1 by 5 and Rp is 5 ohm. Now this 5 ohm is connected in series with the third resistor, which is of 10 ohm. So the resistance in series is 5 plus the 10 ohm, which is 15 ohm. Hence the overall resistance comes to be 15 ohm in this combination, in which we have connected two in parallel with one in series. Let's look how the diagram would look like. These are the two resistors in parallel with the third one in series. So this should be the combination of resistors in which two are connected in parallel with the third in series. Now let's solve the second part of bit C. It says a battery of 6 volt is connected in series with a combination of 5 resistors of these values. So how much current would flow through the 0.3 ohm resistor? So first let's draw the circuit diagram. So there are 5 resistors having value 0.1, 0.2, 0.3, 0.4 and 0.5 ohm, and these all are connected in series, and the potential difference of this circuit is 6 volt. We have to find out the value of current that is flowing through the third resistor, that is 0.3 ohm. Now the current flowing in the circuit will be determined by the overall resistance of this circuit. Now let's find out the overall resistance of this circuit by adding all the resistors together because they are in series. So Rs is 0.1 plus 0.2 plus 0.3 plus 0.4 plus 0.5, which gives us a total of 1.5 ohm resistance. The potential difference is given here as 6 volt. Now using Ohm's law, V is equal to IR. The current in the circuit will be V by R, which is 6 by 1.5, which is 60 by 15, that is 4 ampere. Hence the current in the circuit is 4 ampere. Now this value of current will flow in the entire circuit. So the value of 4 ampere will be through the entire circuit, and because current has only one direction to flow or one path to flow in this circuit, so 4 ampere current will pass through all these resistors. Hence the question is how much current would flow through the 0.3 ohm resistor. So we'll write 4 ampere current will flow through the 0.3 ohm resistor. As in a series combination, the current remains same across all resistors. So this is the solution to this question. It was a lengthy one, but yes, I hope you have understood the solution to this question. If this video was helpful to you, please like this video, share it and subscribe to the channel. Thanks for watching. Please watch the playlist containing the solved physics questions and numericals from the previous year's board exams. I've shared the link of the playlist in the description box. It will be very helpful to you while preparing for your exams. Parallel to the current axis.